Hey Pre-Calc, in this video I'm going to be teaching you about how to find a solution in an interval using sum and difference identities. And this is going to be a little bit more challenging than the other interval problems we've done. So we're just going to do one example, find all solutions on the interval hard bracket 0, 2 pi soft bracket. So the equation we're going to do is 2 times sine of 4x times cosine of 2x minus 2 cosine of 4x times sine of 2x equals -1. Alright, so if we look at the equation we're given, you'll notice that this term and this term both have a 2 in common. Okay? They both have a leading term of 2. So we can factor out the greatest common factor of 2. Rewrite everything. Alright, and then because we have sine cosine minus cosine sine, this is the difference, the difference identity for sine. So using that identity, I'm going to rewrite this as sine of the first angle, which is 4x, minus 2x. I guess we don't need all these parentheses, but whatever. Okay, so I'm going to subtract here. So we have 2 times sine of 4x minus 2x, which is 2x. And then solve for sine of 2x, which will be -1/2. Now, this is where it looks different. So the solving part's not too bad, but at this point, it looks a bit different because this is a 2x and we're used to it just being x. So we're going to take some additional notes on this. So since x is being multiplied by something other than 1, we have to be careful when finding solutions. So what we're going to do first, the first thing you're going to do is figure out, well, if we just ignore this 2, what values of sine will give us -1/2. So what sine angles give -1/2 as a solution? So I'm thinking of my unit circle, it's negative, so that's quadrants 3 and 4. And so there are 2 angles where this occurs, right? 7 pi over 6 and 11 pi over 6. Okay, so keeping that in mind, now we want to keep in mind the period. So since the period of sine is 2 pi, we can write equations to help determine all solutions. And I know we're still going to follow the interval, right? But these aren't going to be the actual angles. So what we're going to do is we're going to write our equations. Normally it would be x equals, right, an equation, this plus 2 pi. But it's not x, it's 2x. So we're going to write an equation, 2x equals 7 pi over 6 plus, and normally it's 2 pi and then k, right? So we're going to divide everything by 2. 7 pi over 6 divided by 2, or times 1/2, will be 7 pi over 12. And then this will be pi times k. And then for our second angle, same idea, except our angle will be 11 pi over 12 plus pi k. Now we can use these equations to help us figure out which angles on the unit circle will exist for this interval. So to do that, we're going to substitute different values for k to determine solutions from 0 to 2 pi. Or we could think of it, right, 24 twelfths. The reason I changed this to 24 twelfths, oops, I forgot the pi, is because, right, these both have a denominator of 12, so if I keep it with the same denominator, it might be easier for me to determine. Alright, so we're going to start when k equals 0. So x equals 7 pi over 12 plus, I'm going to rewrite this as 12 pi over 12. Right, so I'm just replacing pi with 12 pi over 12. And stick here, we're going to do 0. So one solution is 7 pi over 12, which is within this interval. Okay, another solution will be 11 pi over 12. Now there could be more. So what if k is 1? Right, so these are just angles that are basically like coterminal. So x equals 7 pi over 12 plus 12 pi over 12 times 1 is 7 plus 12, it's 19. And then for this angle, okay, 11 plus 12 is going to be 23. Okay, so far all 4 of these are solutions because they're within the interval 0 to 24 pi over 12, or 2 pi, right? If you wanted to check we could go further and say k equals 2, but because this is 23 pi over 12, it's unlikely. But maybe for this one, we have another angle. And we get 31 pi, right? And that's outside of the interval, so we can just stop there. So for a problem like this, you're first gonna solve, right? And then if we have a different period, we want to convert, right, what would have been the answers into the current period and then solve for the angles that are solutions.